Hello guys, welcome to Code Champ. My name is Nikita and in this video we are going to see how to draw 3D objects in GLUT and how to animate them. So for this code to understand, first of all you should check out the previous videos which I have made on GLUT, where I have explained how to draw a very basic simple triangle in GLUT. I have explained each and every function with the parameters, everything is in very detail. Also I have covered how to draw 2D shapes and how to animate them. So how the code changes from like simple animations how you can do all the calculation of the 3D coordinates, how to calculate 3D pyramid coordinates and the 3D cube coordinates. So in the last video we have covered that. So please check out those videos so that you can understand the current video very properly and correctly. So let us start. First of all, I will show you what will be our output so that you will be very enthusiastic to learn the code. So yes, so this is our pyramid which is rotating. This is what the expected output is and we are going to try to achieve this. So let us start. So first thing which we need to change when we come from 2D to 3D is the depth. So what is this depth? So any point in graphics has x, y, z. So this z value counts to the depth of the object. So this z value, if it is 0, if you are not using it at all, then the object will look 2D. And if you want to draw any 3D object, you need to use the z coordinate. Okay. So let us start. So first of all, in 3D, which we need to add is inside initialize function we come and we add this 3 lines. So what does this 3 line mean? So GL clear depth. So let us revise this GL clear color so that you can understand the further GL clear depth very easily. So GL clear color specifies the color with which the color buffer should be cleared. Okay, so this is that color we are specifying. Similarly, we are specifying here the value with which the depth buffer should be cleared. So clearing a buffer means storing this value to that buffer, like cleaning that buffer with like all the other previous values will be cleared and this new value will be stored to that buffer. So why we are storing this depth value there? So we will get to know this now. Next line says enable something. So what we are enabling is depth test we are enabling. In the next line you can see GL depth func and we are specifying here GL underscore L equal, which means less than or equal to. So what is this test? Less than or equal to. So now you will get to know that why we were clearing the depth buffer with 1.0 value. We are going to add z coordinate, so that z value will be checked with this 1.0 and it will be checked accordingly. Like if z value is less than or equal to 1.0, then only that point or vertex will be passed for rendering, like it will be shown on the screen. Otherwise it won't come in the viewport or like it won't be visible on the screen. Okay, so that is what these 3 lines mean. So you can specify instead of L equal, you can also use less, that is GL underscore never, less, then greater. So all other options are available. You can search this function directly and you'll get to know about it. So like I have searched it here and you can see. So this is like multiple values you can specify to this function, and that is GL less, never, equal, L equal, greater, not equal, G greater than equal. So or GL always. So all these values you can try out and like for the different z values. So in our case the z value is going to be in between 0 to 1 and that's why I am specifying here 1.0. So the next change is present inside display function. So let us go to the display function. So you can see the first line which we were writing here was GL clear. So GL clear means it specifies which buffers to clear. First entry here was, which was earlier written, was clearing color buffer. Okay, Now we are also adding depth buffer bit. Why? Because we want depth buffer to be cleared with the value which we have specified, and that is 1.0. So this is the second change. Now here the translate, you can see we are keeping x and y same, like 0 we're not changing it, but we are moving that pyramid little bit like into the screen. So that is minus 6.0, we are pushing that pyramid away from us, so into the screen. So rotate, so why we are rotating the pyramid, like we are animating it, so we want to see how our pyramid is actually looking, because it is in 3D. If it doesn't move, you cannot imagine that oh, this is a 3D object or it is a 2D object. That's why we are animating it. So this angle pyramid is going to be, so we are going to rotate it along y-axis, so that's why this angle pyramid, and here y 1.0. so this angle pyramid will be incremented inside, will be updated in the animate function. So let us go to the vertices of the pyramid. So our pyramid is having 4 triangular faces, and the base of the pyramid is a square. So first I have shown for you like front face how it will look like. This is the apex, and then this is apex, and this is the left bottom, and this is the right bottom. So similarly this one, the right face would come this way, and this would come, left face would come this way, and the back face would be like this. So same. So the front face, you will see there are 3 vertices I am specifying, right, and 3 colors. So apex will be red. If you have seen in the output, the apex is red I have kept, and the next like left bottom is green, and the right bottom is the blue. So 3 vertices we require here. Now front face is over. Now right face. So why I am giving different colors to like different vertices, because it will look very appealing to the eyes. It looks very nice. So if you want to give same color to all the vertices, your whole pyramid will be of one color. And to find the difference between the edges, like when the pyramid rotates, so at that time the edges won't be visible that clearly. So if we specify like this, then you have already seen the output looks very amazing. So the next is back face we are providing. So this vertex calculation I have already explained in the previous video. So if you are not getting how to calculate this vertices, please check out that video. Okay, so next is the left face. Last line and display is GLUT swap buffers. What is this function doing? This function is swapping front and back buffers, so that the next image which is ready for the presentation to be rendered, to be shown on the screen, is swapped. Okay, and the next image will be, again it will be prepared for the rendering. So that's why we are swapping front and back buffers. So inside animate function, what we are doing is we are updating our angle pyramid with the 1.0 value, which is initialized to 0.0 globally, and we are checking whether this is greater than or equal to 360 degree, because angle is always 0 to 360 degree. If it is going beyond 360, please re-initialize it to 0.0, so that the pyramid looks continuously moving and it doesn't stop when it reaches from 0 to 360. Okay, we are posting redisplay message again. Why? Because we want we want display to be called again, because angle pyramid value is updated, right? Yes, so let us see the output again. So yeah, so this was very 3 steps, only 3 changes we have done in our code, and 3D pyramid, rotating pyramid, you can see it looks very amazing. So you see now here the apex is red color, and the edges you can see very properly because I have colored them differently, green and blue, that's why. So the speed is very high of this pyramid. So what we will do is we'll try to change it. And how to change that? Simply I am changing here 0.5 f. I'm doing it, and I will execute it again, and we will see the difference. So here the speed of the pyramid is reduced now. Yeah, this is a very good speed. Okay, so that is it for this video. In the next video we are going to see how to apply textures in GLUT. So thank you guys for watching this video. Enjoy coding. Keep